Let's try a couple more examples with finding the centroid of a region. In this case, we're looking at the region bounded by the curves y equals cosine x, from y equals the curve y equals 0, x equals 0, and then the line x equals pi over 2. So we have the cosine curve. So there's just part of it there going between the y-axis and the x-axis, and then the line pi over 2 here. Okay, so we're looking at this region R that's between. So notice that this one doesn't have any symmetry that we can exploit. So we'll just use our formula for x bar and y bar. So for x bar, integral of 1 over a x f of x. And then for y bar, 1 over a integral 1/2 f of x squared. In this case, the f of x is the cosine curve. And then we're bounded between 0 and pi over 2. To get a, we want the area of the region, which is just going to be integrating from 0 to pi over 2 cosine x. Of course, we know that's negative sine x. I'm sorry, positive sine x. Evaluated from 0 to pi over 2. Notice here we get sine of pi over 2 is 1, sine of 0 is 0, so here the area is just 1. Okay, so now let's find x bar. 1 over a is just 1, and then we'll integrate from 0 to pi over 2. X f of x, so x cosine x. Okay, so to do this integral, now we'll do a little integration by parts. So let u equal to x, dv equals to cosine x. So du equals dx, v equals sine x. So according to the parts formula, we'll have x sine x evaluated from 0 to pi over 2 minus the integral from 0 to pi over 2 of sine x. Okay, so we have pi over 2 sine of pi over 2, which is 1, minus 0. And here when we integrate sine x, it'll be negative cosine x. Okay, we know cosine of pi over 2 is 0, and cosine of 0 is 1. So it'll be 0 minus 1 when we evaluate cosine at pi over 2 and minus at 0. So here our x bar will be pi over 2 minus 1. Let's compute y bar. So again here 1 over a is just 1. And then integral from 0 to pi over 2 of 1/2 cosine x squared. So we can remember now when we're integrating cosine squared, we can just use our power reducing formula. We have 1/2, 1 plus cosine of 2x. Okay. So now we'll have 1/2 times 1/2, we'll have a 1/4 in front. And let me integrate now. So it'll be integral of 1 is x, plus integral of cosine of 2x will be sine of 2x over 2. And then we'll evaluate from 0 to pi over 2. So I'll have pi over 2. Sine of 2 times pi over 2, so the sine of pi is 0. And then 0 plus sine of 0 is 0 as well. Okay, so this will just be pi over 8. Okay, so that's the y bar. So my guess is that we get some centroid somewhere around there. Next, let's suppose we have a region that's bounded between two curves. So we have one curve f of x above and another curve g of x below. So our region R is between them. Here going from A to B. So we can adjust our centroid formula for x bar and y bar just a little bit here to get the formula for this region bounded between two curves. So we'll still have 1 over A, which is the area of that region. And then it'll be x times the upper curve f of x minus g of x to get x bar. And then for y bar, 1 over A, integral from A to B. And then 1/2 the upper curve f of x squared minus the bottom curve g of x squared. So you see it's just a slight adjustment to account for now the slightly different way to define the region here, where we have now an upper boundary and a lower boundary with the curves f of x and g of x. So let's try that with an example where we want to find the centroid of the region bounded by the line y equals x and the parabola y equals x squared. So imagine here there's the parabola and here's the line. So we got the upper curve would be the line and the lower curve would be the parabola, and they intersect here at the point 1, 1. Okay, so our centroid would be somewhere in there. Let's start by finding the area of the region, which would be finding the integral from 0 to 1 of the upper curve minus the lower curve, so x minus x squared. So that'll be 1/2 x squared minus 1/3 x cubed, evaluated from 0 to 1. So we'll have 1/2 minus 1/3, which is 1 over 6. Okay, so that's the area of our region, 1 over 6. So now to get x bar, it'll be 1 over A, so 1 over 1 over 6. Integral from 0 to 1 of x times upper curve minus the lower curve, x minus x squared. So let's work this out. 1 over 6 is just 6. Distributing the x, we have x squared minus x cubed. Integrating that, we have 1 over 3 x cubed minus 1 over 4 x to the 4th. And then evaluating from 0 to 1, I'll have 6 times 1/3 minus 1/4. Which will be 6 times 1 over 12. So that gives me the centroid for the x coordinate is at 1/2. 6 over 12 reduces to 1/2. Now let's do y bar. Okay, so y bar again is 1 over A, so 1 over 6, integral from 0 to 1 of 1/2 the upper curve squared, so x squared, minus the lower curve squared, so x squared squared. So here again we got 6 times 1/2. And then we've got x squared minus x to the fourth. 6 over 2 is 3. Integrating, we have 1 over 3x cubed minus 1 over 5x to the fifth. Evaluate from 0 to 1. So that leaves me with 3 times 1/3 minus 1/5, which I believe is 6 over 15. Okay, so that gives me my centroid now. X bar, y bar is the coordinate 1/2, comma 6 over 15.